Hi, Mrs. Vara here with a short video to go over the Chapter 9 pre-test warm-up. Okay, so the first one is a simplify. And so I want to do a jailbreak on this. Now, right away, I am noticing that 64 is a perfect square. It's on the perfect square list. And remember, I said multiple times, if you memorize the perfect squares, it'll save you some work. So if you recognize it as a perfect square, you know it's the same as 8 times 8. So I can rewrite this as 8 times 8 and then 6 y's. 1, 2, 3, 4, 5, 6. And remember, it's a root 2, so I need groups of 2 for a jailbreak. So 1, 8 will get out alive there. 1 y, circling all my groups of 2, another y, circling my last group of 2. I've circled everyone in the jail, so that means the jail is empty. I no longer need it. Outside the jail, I have an 8 and 3 y's, so that's y to the third power. So that is fully simplified. This one here is my radical. I need to do a jailbreak on this if possible, or simplify this, but 3 is a prime number, so I know the only factors of that are 1 and 3, so that is fully simplified. However, remember, a radical in the denominator of a fraction is a no-no, so I need to rationalize the denominator. And remember, when I do that, all 3 of these radicals are going to be the same. So square root of 3, square root of 3, square root of 3. Now I'm multiplying fractions. Remember, start with a fraction, end with a fraction. So my numerator is 10, not in jail, times square root of 3 is just 10 times the square root of 3. Don't put that 10 in jail. They are not in jail. They will be outside the jail. On the bottom, I have square root of 3 times square root of 3. So remember, that's basically this. For multiplication, I can put them in jail together. But then the 3 will escape. So what I have is 10 square root of 3 over 3. So I have eliminated the radical in the denominator. Then remember, you want to cover up the jail and check your fraction outside the jail. Can that be simplified? Can 10 over 3 be simplified or reduced? It cannot, so then I'm done. But make sure you do that check. Hint, hint, make sure you do that check on the test. Okay, number 3 is adding and subtracting radicals. So remember, like radicals, such as square root of 5 plus square root of 5 would be 2 square root of 5. Like radicals can be combined, but if you look at this, it doesn't appear as though I have any like radicals. But I need to simplify first. So 20 is the same as 2 times 10 and 2 times 5. So there's all my prime numbers. Square root of 20 can be written as 2 times 2 times 5. 125, 2 doesn't go into that, 3 doesn't go into that, but 5. So remember, you're just checking. No, 2 doesn't go into that. Divide by 3. Nope. Try your next prime number. If 2 doesn't work and 3 doesn't work, try 5. Oh, there we go. 5 times 25. And then 25 is the same as 5 times 5. So there's my primes. So I'm going to rewrite square root of 25 as 5 times 5 times 5. Okay? And then minus 45 is 5. 2 doesn't go into it. Again, if you check 45 divided by 2, nope. 45 divided by 3, nope. Oh, yes, 45 divided by 3, 15. Let's do that. 3 and 15. And 15 is 3 times 5. Okay, so 45 can be written as 3 times 3 times 5. Now do your jailbreaks. 2 breaks out, 5 is stuck. 2 square root of 5. 5 breaks out, 5 is stuck. Plus 5 square root of 5. 3 breaks out, 5 is stuck. Minus 3 square root of 5. Remember, if we would have had somebody outside of jail here, we would have multiplied whatever broke out by whatever's outside the jail. Now, these are all like radicals. I can combine these into a single square root of 5, and I'm going to add and subtract the coefficients here, or the number multiplied by the radical. So 2 plus 5 is 7. 7 minus 3 is 4. So that simplifies all the way down to 4 square root of 5. Okay, this one has an equal sign. That means it's a solve. That means my answer needs to look like x equals. Remember, often we end up with 2 solutions because we have an x squared. So here's your x trapped inside your second power. My first step is to get this term all by itself on one side of the equal sign. Isolate the radical, isolate the variable. So if I look here, I want this by itself. Who's hanging out over here on this side of the equal sign? The 4. So to undo minus 4, we're going to add 4 to both sides. So then I have 0. And on the left, I have this still inside the power of 2. We have not eliminated the power of 2 yet. 12 plus 4 is 16. Now that this is all by itself on one side of the equal sign, now I can eliminate the power 2 by doing root 2 on both sides. So on the left, power 2 and root 2 are inverses. They undo each other, and I'm left with 2x plus 4. On the right, be careful, I have plus or minus. This is a perfect square. The square root of 16 is 4. So there's my 2 equations that I need to solve. The first one is 2x plus 4 equals positive 4. So nothing changes over here, just the right side. I'm going to use the positive 4, and now I'm going to use the negative 4. 2x plus 4 equals negative 4. Okay, solve for x. Subtract 4 from both sides. 2x equals 0. Divide by 2, divide by 2. X equals 0. Minus 4 from both sides. This time, 2x equals negative 8. Divide by 2, divide by 2. X equals negative 4. All right, one more. Solve, but I can't solve using square roots because I have an x squared and an x. So I want to solve this using quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. First, am I in standard form? Yes, I am. Everything on one side of the equal sign, 0 on the other. So second, find a, b, and c. A is 2, b is 3, c is negative 20. Okay, opposite of b, remember we're going to find the parts separately and then plug in to the formula. So opposite of b, if b is 3, the opposite of 3 is negative 3. B squared minus 4ac is going to equal b squared. 3 squared minus 4, that's a copy job, part of the formula, times a times c, negative 20. Be careful. If you write it just like that with all your parentheses, then you can punch that whole thing in the calculator. So parenthesis 3, parenthesis, oops, not negative 3. Let me try again. Parenthesis 3, parenthesis squared, minus 4, left parenthesis 2, right parenthesis, left parenthesis, negative 20, right parenthesis, equals 169. 169. So that's going to go into my quadratic formula. And the last part is 2 times a, which would just be 2 times 2, which would be 4. Okay, now let's substitute. Negative 3 in here, 169 in here, and 4 in here. So what I have is x equals negative b plus or minus square root of b squared minus 4ac is 169. All over 2a is 4. Simplify your square root first. Now you can do a big tree on this, or if you're paying attention and you memorized your perfect squares, you know that the square root of 169 is 13. Or you can use your calculator. So this is 3 plus or minus 13 over 4. Now, two answers here. The first answer will be negative 3 plus 13 divided by 4. The second answer will be negative 3 minus 13 divided by 4. Okay, simplify your numerator first. Negative 3 plus 13 is positive 10 over 4. You can leave it just like that. Well, actually, you can't. You should simplify that fraction. 2 goes into 10 5 times. 2 goes into 4 2 times. So you can leave it just like that. If you prefer, you can write it as a decimal, which would be 2.5. I'm just going to leave it as a fraction. X equals 5 over 2. Let me slide this over a little. Okay, negative 3 minus 13, negative plus a negative makes a bigger negative. So that's negative 16 in your numerator divided by 4. If you put that in your calculator, you're going to get negative 4. So your second solution is negative 4. All right, that is it. Good luck on your test.